Hi, this is Victor and welcome back to my math tutoring channel. In this video, we'll find the solution of that integral, which is x dx divided by x to the power of 4 plus 3x to the power of 2 plus 2. And the technique that I will use is factorization of quadratic equation, logarithmic rule, and partial fraction decomposition. So let's start. If I look at my integral, if I look at the denominator, I see x to the power of 4. Don't get intimidated by x to the power of 4. Let's make it like quadratic equation. To make it a quadratic equation, I can say let y is equal x to the power of 2. So my denominator become y to the power of 2 plus 3y plus 2. And this is a quadratic equation. And now I can factor out my denominator. The formula to factor it out will be y equal minus b plus or minus square root of b squared minus 4 times a times c divided by 2a. And in that case, my a is equal to 1, my b is equal to 3, and my c is equal to 2. So let's apply the formula. So my y1, or my y for now, I'll split it into y1 and y2 in a minute. Minus b, it's minus 3 plus or minus square root of minus 3 of 3 to the power of 2 is 9. Minus 4, my a is 1 and my c is 2. And all that divided 2 times 1 is 2. I know 4 times 1 times 2 is 8. 9 minus 8 is 1. So my y become minus 3 plus or minus 1 divided by 2. So now let's split it. y1 will become minus 3 minus 1 divided by 2, and y2 become minus 3 plus 1 divided by 2, and this is equal minus 4 divided by 2, it's equal minus 2, and this is equal minus 2 divided by 2, which is equal to minus 1. So I have y minus equal to minus 1, and I have y equal to minus 2. So that means y minus 1 is equal to 0 and y plus 1, because like the minus come to the left hand side of the equality, it changed its sign, and then I have same logic, y plus 2 is equal to 0. So my denominator, which was y to the power of 2 plus 3y plus 2, will become y plus 1 times y plus 2. And now let's replace y by its value. We said y is equal to x squared. So my denominator become x squared plus 1 times x squared plus 2. So my integral become the integral of x dx divided by x squared plus 1 times x squared plus 2. So here I can say let u is equal to x squared plus 1. So my du is equal to x dx, but in my numerator, I do have x dx. I don't have 2x dx, so the 2 is bothering me. I know that x dx is equal 1/2 du, or du divided by 2. And because here I have x squared plus 2, so let's calculate what is x squared. So if I bring the 1 to the left hand side, it becomes minus 1. So u minus 1 is equal to x squared, and x squared plus 2 will become, I replace x squared by u minus 1, and then I have the plus 2 here. It becomes u plus 1. So my integral will become, instead of x dx, it's 1/2 du, but the 1/2 is a constant. I can put it outside, become du. And then I know x squared plus 1 is equal to my u, and x squared plus 2 is equal to u plus 1. So now I can do the partial fraction decomposition. Let's take what's inside the integral, which is 1 divided by u times u plus 1. And here, if you want to know how I came to that formula, a divided by u plus b divided by u plus 1, I have a lot of video that explain the partial fraction decomposition. You can look me up, Vic the Math Tutor, one word, and then search for partial fraction decomposition. You will find a lot of videos for that. So now let's have the common denominator on the right-hand side of the equation. Let's keep the left-hand side as is equal. The common denominator will become u times u plus 1, and my a times u plus 1 plus my b times u. And now let's factor out or multiply a by u plus 1. So I have 1 divided by u times u plus 1 is equal a u plus a plus b u divided by u times u plus 1. Because I have the same denominator on the left hand side and the right hand side of my equation, I can factor it out. So my equation become 1 equal, and then here I can factor out u, a plus b times u plus a. And on the left hand side, I don't have anything with coefficient of u. That means my a plus b is equal to 0. That means my a is equal to minus b. And that a here does not have a coefficient of u, and the 1 here does not have coefficient of u. That means my a is equal to 1. So my b would be equal minus 1, because a plus b is equal to 0. So my fraction, the 1 divided by u times u plus 1, I can write it as, we said a divided by u, and the a is equal to 1, so 1 divided by u, and the b is equal minus 1, so minus, because like this here, plus times minus is minus, the b is 1, minus 1, and then u plus 1. So my integral become integral of 1 divided by u minus 1 divided by u plus 1. All that is du, but I have 1/2 before, and that's the 1/2 here. And now it become easy to solve. Because of that minus, I can split my integral into two integral. It become 1/2 integral of du divided by u, and the 1/2 is for both of them, minus integral of du divided by u plus 1. And that's easy to solve. I know it's a formula. 1 divided by u, the integral of 1 divided by u is log of u. So 1/2 log of absolute value of u. We put absolute value before the logarithm because we cannot have a log of a negative number, minus log of u plus 1, and all that plus c. And here I will apply the logarithmic rule, which said log of a divided by b is equal to log of a minus log of b. And in my case, I have the a is u and my b is u plus 1. So that would be equal 1/2 log of u divided by u plus 1 plus c. And now let's replace u by its value. We said u is equal x2 plus 1. Here it is. My u is equal to x2 plus 1. That square is for this x. So it become 1/2 of log of u of x2 plus 1 divided by x2 plus 1 plus 1 plus c. So it is 1/2 log of x square plus 1 divided by x square plus 2, absolute value here and there, plus c. So that would be the end of my video. If you like my video, please subscribe to my channel. That would help me tremendously. And if you push the like button, I would really appreciate it. Thank you for listening.